Welcome to your IELTS listening practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
In our environmental science lecture today, we are going to discuss a growing and deeply worrying global problem, one that is largely invisible to those of us on land: ocean dead zones. Imagine a vast expanse of ocean that looks perfectly normal on the surface, but beneath the waves, it is almost entirely devoid of life. This is the reality of a dead zone. Let's begin with a clear definition. A dead zone is a more common term for a hypoxic zone. Hypoxic simply means low in oxygen. These are areas of the ocean where the concentration of dissolved oxygen is so low that most marine life simply cannot survive. While these can occasionally occur naturally, the vast majority of the hundreds of dead zones that now exist around the world are caused by human activity. The primary cause is nutrient pollution from land. The two main culprits are nitrogen and phosphorus. These chemicals run off agricultural land into streams and rivers, which then carry them out to the coastal ocean. And where do they come from? Overwhelmingly, they come from the huge quantities of agricultural fertilizer that are used in modern industrial-scale farming. The mechanism that creates the dead zone is a well-understood process called eutrophication, which you might have studied in other contexts. When these excess nutrients, the nitrogen and phosphorus, enter the water, they act like a super fertilizer for tiny marine plants called phytoplankton, causing massive population explosions or blooms of algae. These blooms can be so dense that they turn the water a thick green or even red, and they block sunlight from reaching important habitats like seagrass beds on the ocean floor. Now, the problem isn't the algae themselves when they are alive, but what happens when they die. Their short life cycle ends, and they sink to the bottom of the ocean. There, huge colonies of bacteria begin the process of decomposition. This process is highly oxygen-intensive. The bacteria respire just like we do, and in breaking down the dead algae, they consume enormous amounts of the dissolved oxygen in the surrounding water. It is this bacterial action that creates the severe hypoxic conditions that define a dead zone. The impact on marine life is, of course, catastrophic. Animals that are mobile, like adult fish, can sometimes flee the area as oxygen levels drop, though they are often forced into smaller, less suitable habitats. But slower, less mobile creatures that live on the seabed, things like crabs, lobsters, oysters, and worms, are trapped. They cannot escape, and as the oxygen vanishes, they simply die, leading to a massive ecosystem collapse on the seafloor. This is a truly global problem. While the dead zone in the Gulf of Mexico, fed by the Mississippi River, is perhaps the most famous, there are now over 400 documented dead zones around the world. In fact, the world's largest, in terms of sheer area, is now believed to be the one in the Arabian Sea, which at times covers an area almost the size of Scotland. It's a vast, lifeless expanse, and the trend is not encouraging. Data collected over the past few decades by scientists worldwide shows a clear and alarming pattern. The number of known dead zones has roughly doubled every 10 years since the 1960s. So this is a problem that is definitively worsening in size and number, driven by the intensification of global agriculture. Tackling this issue is incredibly challenging. One of the main difficulties is a matter of geography and politics. The pollution does not originate on the coast. It originates from thousands, sometimes millions, of farms and cities, often hundreds of miles away, deep within a continent. The key problem is that the pollution often comes from sources far inland. This makes it a vast, multi-state, or even multinational issue to manage. requiring cooperation across many different political jurisdictions, which is notoriously difficult to achieve. So what are the solutions? The most obvious one is to tackle the problem at its source, reducing the amount of fertilizer running off farmland. This can be done through more precise, technology-guided application and by creating buffer zones of natural vegetation along rivers. But other nature-based solutions are also crucial. For example, a key proposal involves restoring coastal wetlands like salt marshes and mangrove forests. These ecosystems are brilliant natural filters. They can absorb huge amounts of nutrients and sediments from river water before they reach the open ocean, acting as the coast's kidneys. To conclude, while the term dead zone sounds final and permanent, it doesn't have to be. These zones are not necessarily permanent. Studies have shown that if the flow of pollutants is significantly reduced, ecosystems can be surprisingly resilient and can recover over time. Therefore, the main message to take away is that this is a reversible problem requiring urgent action, both on our farms far inland and in the protection and restoration of our vital coastal habitats.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.